students, welcome back to my channel. My name is Prachi and today we will be working on the third part of hydrogen chloride. In today's session we would work on the physical and chemical properties of hydrogen chloride gas. As we go along in the chapter, we would also discuss some important questions that may show up in your examinations. So stay tuned and let's get started. Okay students, I hope you can see my screen now. So let's start with the physical properties of HCl gas. So we'll begin with the color of it. So HCl is a colorless gas. So it is a colorless gas. If we talk about the smell, it has a pungent choking odor. That means it has a pungent choking smell and it is very identifiable. Like once you do smell HCl gas, you'll understand how pungent and choking it can be. So it is a pungent choking smell. Moving on to the taste. So it is sour in taste. Sour as in most acidic compounds are sour in taste. So it has a similar taste like that. Now physiological nature, it is corrosive in nature. When we say corrosive in nature, that means it is very irritating for eyes, our nose, throat, and for the skin. So it is quite irritating for our sensitive parts of the body. Then if we move on to density, it is heavier than air. So it is heavier than air. That is the reason when we collect HCl gas in the lab preparation, we collect it by the upward displacement of air. Because it is heavier, so it would easily settle into the jar and help the air move out of the jar. Moving on to solubility. So it is highly soluble in water. How much it can dissolve? So 1 part or 1 volume of water can easily dissolve about 452 volume of HCl gas. That is how much soluble HCl gas can be when we talk about water. Since HCl is a polar covalent compound, so it is a polar covalent compound, it is also soluble in some organic non-polar solvents like acetone and toluene. So like acetone and toluene. What are acetone and toluene? They are non-polar organic solvents. So your HCl gas is easily soluble in these two compounds as well. Alright. Moving on to the experiments for HCl gas, we have 2 experiments that we will study and both of them are really important. So the first experiment is to demonstrate that the HCl gas is heavier than air. We have a very simple experiment for this. We have a beaker, we have a candle lit inside and we pour in HCl gas into that. Now when we pour in HCl gas, what happens is since HCl gas is heavier than air, it will slowly start settling down and it will slowly start pushing out air from this beaker. Now since air is pushed out and HCl gas will slowly start coming up to the brim, the candle cannot be lit anymore. So the candle gets extinguished and this reaction of the candle tells us that there is no air in the beaker anymore. Hence demonstrating that HCl gas is heavier than air. So this is the first experiment. Now what kind of question can we expect from this? They can either give you this diagram and ask you what's happening, or they can give you the demonstrate, like they can give you the aim of the experiment and ask you how would you prove that HCl gas is heavier than air. How would you do that? Then you end up making the diagram and explaining it. Alright, moving on to experiment number 2. This is known as the fountain experiment. What are we representing here? We are looking at how to demonstrate that HCl gas is highly soluble in water. This is a very important experiment. I have seen this reappear in a lot of exams. Now let's understand the apparatus first. Let's look at what do we have in the setup. So the first thing that we have is that we have a round bottomed flask, that's this one. This contains HCl gas, and we always mention that this gas is dry here. Then in this bottom part we have two holes through which one we have a rubber dropper. This is a rubber dropper. And through the other one we have a jet tube which is going down into a blue litmus solution. Okay. So this is the basic apparatus that we have. We have a round bottomed flask, a jet tube, a rubber dropper which will have water in it. So this has water in it. And blue litmus solution in the tub below. So this is the blue litmus solution. Now let's understand what do we do here. So the first thing we do is, just a second, yeah. So the first thing we do here is that we press the rubber dropper. As we press the rubber dropper, small amount of water from the top enters here into the round bottomed flask. So some water comes here. As soon as water enters into the round bottomed flask, a lot of gas of HCl gas is dissolved in water. When HCl gas dissolves in water, it creates low pressure inside. So over here we have low pressure created. As the low pressure is created through the jet tube, we have a sudden rush of blue litmus solution going into the round bottomed flask. As the blue litmus solution enters up here, because HCl gas is acidic in nature, it will turn the blue litmus solution to red. Therefore, we start looking at the water that's coming here is red in color. So you look at a red fountain being created in the round bottomed glass jar. So this is the basic understanding of the experiment. Let's look at it again and understand the working. The first thing we do is we press the rubber dropper. When we press, some amount of water enters into the round bottomed flask. As the water enters there, the dry HCl gas will dissolve in water very quickly, which will create a low pressure inside the round bottomed flask. Once low pressure is created, that makes our blue litmus solution go up into the round bottomed flask. Now, due to the acidic nature of hydrogen chloride gas, the blue litmus solution will turn into red litmus solution, and we look at a red beautiful fountain on the top. So this is the basic understanding of the fountain experiment. If you have any doubts about this experiment, please drop a text in the comment section below and I'll address that too. Now let's look at the common questions that we can see in the exam. So the first question is that we can get name an experiment which is used to demonstrate that HCl gas is highly soluble in water. So that is fountain experiment. Fountain experiment. Now one more thing over here. Another question that we can get is, what does fountain experiment demonstrate? So it demonstrates high solubility of HCl gas in water. So these are like 1 marker questions that you can see in the exams. So now let's move on. Okay students, moving on to chemical properties of HCl gas. So the first chemical property that we have is combustibility. So HCl gas is neither combustible, HCl is neither combustible and nor a supporter of combustion. Now which gas is a supporter of combustion? Oxygen gas is a supporter of combustion. So you have oxygen, a supporter of combustion. But is oxygen combustible itself? No. The answer is no. Oxygen not combustible itself. Whereas if we think about hydrogen gas is not a supporter of combustion, but it is combustible itself. So hydrogen is combustible but not a supporter of combustion. So every different type of gas that we will study, we'll understand its combustible nature, whether is it itself combustible or not, is it a supporter of combustion or not. So similarly, in HCl, neither combustible nor a supporter of combustion. Now, moving on to thermal dissociation. What would happen if we provide heat to HCl gas? So you have HCl gas and I heat it, let's say above 500 degrees Celsius. What would happen to it? It will break down into the two consecutive gases that it is made up of. That is hydrogen gas plus chlorine gas. And if I balance it, this becomes 2HCl, giving us hydrogen plus chlorine. So this is also a gas and these two are also gases. Now, if you get a question in the exam, write a reaction in which two gases combine to form a new gas. So what we will get? We will get hydrogen plus chlorine giving us HCl. Then, if they ask name a gas which on heating gives two other gases, what do we get? We get HCl as a gas breaking down into hydrogen plus chlorine at above 500 degrees Celsius. So these are the two reactions, these are the two questions that you can get around the same reaction. Okay, moving on to reaction with metals. So as per the reactivity series, all the metals which are above hydrogen and they can easily replace hydrogen will form their corresponding chlorides when they react with HCl gas. So sodium plus HCl gas will give us NaCl plus hydrogen. Calcium will give us CaCl2, magnesium will give us MgCl2, Fe will give us FeCl2, plus hydrogen gas will come out with all of them. Whereas if we look at copper, copper will not react with HCl because copper is below in the reactivity series. So this reaction will not happen. So no reaction here. Now the fourth part of the chemical property, reaction with ammonia. So when we have ammonia, NH3 plus HCl, that gives us NH4Cl. In this case, what is happening is you have ammonia gas reacting with HCl gas giving us ammonium chloride, that is dense white fumes. So dense white fumes, but the catch here is that this is a solid compound. So you do get dense white fumes along with it and you have a solid compound being formed. So two gases combining to form a solid. Now, what kind of questions do we expect from this? Two gases combine to form a solid. You directly get this answer right here. That is ammonia gas plus HCl gas gives us ammonium chloride. So students, this is where we conclude today's session. We have covered the physical and chemical properties of HCl gas in this session. For previous sessions, feel free to check out the playlist and understand those parts. For any questions or queries, feel free to drop a message in the comments section below. I have attached the notes for today's session in the description box. In the next session, we would move ahead to HCl acid, the preparation and properties for that. Thank you so much for all your love and support. Please like, subscribe and share this video and help me move forward. Thank you.